In this video, we're going to work through the chapter Data Transformation from the book R for Data Science. Data transformation is the process of essentially reworking your data to get it to a form that's going to work well for the analysis and visualizations that you want to run on it. For some examples of things you might do as part of the data transformation process, you might narrow down your data to observations of interest. For example, all the people in one city or all the data from a particular year. You might create new variables that are functions of existing variables, such as computing speed from distance and time. Or you might calculate a set of summary statistics for your data, like counts or means. Data transformation might also include just basic housekeeping of the data. Maybe the data set you're working with has variable names that are just unclear or don't make sense and you want to rename them for clarity. Or maybe the data would make more sense if the observations were reordered in some more logical way. All of these transformations are just part of the wrangling process necessary to get your data to a place where, like I said, it's ready to visualize and analyze. In this chapter, the tools that we're going to be using for data transformation come from the Dplyr package. This is part of the Tidyverse family of packages. And Dplyr is short for Dplyr, where Plyr is just a play on the actual plier tool that you might find in a regular toolbox. And so the idea is it's just providing a series of useful and universal tools for transforming your data. For a sampling of those tools or functions you're going to encounter when working with Dplyr, here in the documentation we could see it highlights 5 functions. There's mutate, select, filter, summarize, and arrange. And if you take a moment to pause and read these descriptions, hopefully you can see how these functions would help address some of the goals I highlighted a moment ago. So now that we understand how we're going to accomplish our data transformations, let's jump right in, switching over to RStudio. I've got a blank R script where I'm going to work through the examples in this chapter. If you're just joining us, a reminder, the way we can create a new R script is just clicking this little plus icon on the top left in RStudio. And then the first thing I'm going to do in my script is use the library command to pull in the Tidyverse family of packages to make sure I have access to that Dplyr package. And then to execute this line of code on my Mac, I'm going to hold down the keyboard shortcut Command Enter. If I was on Windows, I would hold down Control Enter. And if you are starting with a new R session and Tidyverse previously hadn't been loaded, you'll see output like this. If Tidyverse had previously been loaded, you wouldn't see this output, and you can just assume that the Tidyverse packages have been loaded. And of course, we can just double check that Dplyr is included there. Now, from this output, we see that there are some conflicts, and this is something we have glanced over in previous chapters. Let's take a moment now just to look at this and understand what this means. The first line is just telling us that the Dplyr package has a function called filter, but we also have a stats package that's currently loaded that has its own function called filter. So what that means is if we invoke filter in our code and execute this conflict is telling us that it's Dplyr's filter that's actually going to be executed because it's masking the stats filter. So in this situation, let's say we explicitly did want to use the filter function that comes from the stats package. We could still do that in our code. We would just have to be more explicit by prefixing the function name with the package name. So that would look like this. We would say stats : then the function name. Right? That's going to make sure it's getting filter from stats versus this would just get filter from Dplyr. Now, as for our work in this video, when we're using the filter function, we do want it from the Dplyr package. So this is how we're going to reference it. This approach here and just talking about conflicts is a little FYI that's included at the start of this chapter. So I just wanted to make sure I addressed it. And they also mention how if you ever see this syntax in documentation or tutorials where it's the name of the function or the object prefixed by the package name, separated by double colons, they're indicating that just to be super clear where that function or object is coming from. What is the parent package? So just a bit of a syntax aside, getting back on track, the other library we want to import is the example dataset we're going to be using in this chapter, which is called NYC Flights 13. This dataset contains information about flights that departed New York City in 2013. Let's go ahead and pull in that library by executing that line of code and then use the view function to get familiar with the data from this package. And the data itself is simply just called flights. So it looks like we've got over 300,000 observations and 19 total columns or variables. Variables include information about date, such as year, month, and day, time information related to departure, time information related to arrival, and so on. You could skim through the other variables and get a sense of the information we have to work with. So with our data ready to go, let's start with a very basic transformation. Let's just filter our data. Specifically, let's filter down to flights that departed from LaGuardia or LGA. For this, we're going to use the filter function from Dplyr. And the first argument to any of the Dplyr functions is always going to be the data you want to be performing the operation on. So in this case, that's going to be flights. Then following that, you want to indicate what column you want to filter by. So in this case, the variable we're focusing on is the origin, and we want to match any of the observations where the origin is equivalent to LGA. Now notice I used a double equal sign here. This wasn't a typo. This is the equality operator, and it's used anytime you're trying to determine if two values are equivalent to one another. Let's go ahead and run this line to see the results. So we can see that yielded a output of a tibble, which you'll recall from previous chapters. A tibble is just like a enhanced version of R's data frame. We can see we got about 100,000 observations. And because the way tibbles are printed, it is truncating the variables we're seeing for these observations. You could see that 12 or more variables were actually obscured. So let's actually rerun this and wrap it in our view function just to get a clearer picture of this data. So let me run that again. And just like we saw in the console, we've got over 100,000 entries across 19 total columns, but now we can actually see all those columns. And what I want to look at specifically is just the origin and make sure they all match what we looked for, which was LGA. And it looks to be the case. Just for comparison, let's check out the difference between LaGuardia and JFK. So a similar amount of flights departed from JFK, but a little bit more than we saw with LaGuardia. And again, if we look at the origin, we should see JFK for all of our results. Building on this example, typically when you're working with Dplyr, you're going to be working with your data in multiple steps. For example, let's say we're trying to answer the question for flights departing from JFK or LGA or whatever airport. We want to know what the average arrival delay is for each month in the year. Getting this information is going to require 3 steps, right? So step 1 is filtering down to the particular airport we're interested in looking at. Step 2, we're going to need to group the results by month. And then step 3, we're going to need to calculate the mean of that arrival delay variable. So those are our 3 steps, and we've already done step 1 of filtering. So let's build on this for step 2, where we're going to group our data by month. To accomplish that, we are going to be using Dplyr's group by function. And as I mentioned, any function in Dplyr typically is going to start with the data we want to be grouping by. Now, in this case, we don't want to just group our flights data. We want to take the results from our filtering. That's what we want to group. So I'm actually going to take that and add that as the first argument to group by. Then for my second argument, I want to indicate the variable I want to group by, which in this case is going to be month. And then the third and final step is to calculate the mean of the arrival delay. To do that, we're going to use a Dplyr function called summarize. So once again, I want to take this entire result that I have constructed so far, and that's what I'm going to pass as my data to the summarize function. So we'll say summarize, there's the data we're passing. And then for the second argument, we're essentially going to overwrite our arrival delay variable, and we're going to set it to be the mean of our arrival delay data. And here I'm just using R's built-in mean function. I am going to pass it a second argument of na.rm is true. If I don't do that and I have missing data for arrival delay, which I believe this data set does have, this would return na. So we don't want that. We just basically want to exclude any missing values. And then we'll have our closing parentheses for the summarize function. Now, this line is getting quite hefty and very confusing at this point. We're going to see how we can clean that up in a moment, but let's just make sure this is giving results that we're expecting. I want to run this, and let's do this. Let's set these results to an object. So I'm just going to create an object name called results. I'll use my assignment operator, and then that way I can have my view function afterwards, like so. All right, so let's run that to build results, and then let's view the results. And perfect, there is our transformed data. So we see for each of the 12 months in the year, the mean arrival delay for flights, in this case, departing from JFK. So we got the results we were looking for, but as I mentioned, this is quite a hefty line. There's a lot going on here, and it's really hard to decipher the different parts. It also doesn't have a logical flow because we're starting with summarizing, which is actually the last step in the process. So as a result, we kind of have to read this inside out. We have to drill down to the first step in the process, which is the filtering, then work our way out to the grouping, and then finally the summarization. So long story short, this is a hot mess. And to address this sort of mess, the Fine developers of R and also Tidyverse introduced something called the pipe operator. The pipe operator allows us to alter the way we invoke functions so that we can start with the data we want to work with and pipe that to functions, allowing us to invoke our functions in a logical order, right? Start with filter, then group by, then summarize. Let me show you what I mean. So let's comment out this mess of a line and let's rewrite this using the pipe operator. The first thing we're going to indicate when using a pipe operator is the data we want to start with. So in this case, that's going to be flights. And then we're going to use R's built-in pipe operator. The syntax for that is we're going to use the pipe character followed by the greater than sign. So this data is going to get piped in as the first argument to whatever function we follow the pipe operator with, which in this case, we want to start with filter. Now, because we've piped in the data using the pipe operator, we don't have to pass in flights as the first argument to filter like we did previously. We're simply going to skip over that and go to the second argument, which was setting our origin. Then the next step is we want to take this data that we filtered and we want to pipe that to the group by function. So once again, we'll use our pipe operator, group by. We don't have to indicate the data that's coming from before the pipe character, but we do have to indicate our second argument, which in this case was month. And then finally, we want to take that resulting data and pipe it to our final function, which was summarize, which the argument we pass that, aside from the data, which we're getting from the pipe, is going to be arrival delay. We're going to set that to be the mean of arrival delay. And what you can do when you're using the pipe operator is introduce line breaks to make things clearer. So after the pipe operator, before you indicate your next set of data, we're just going to put a line break. So again, after the pipe operator, line break, after the pipe operator, line break. And then here is our resulting code, which let's go ahead and run this just to make sure we're getting the same results we got in the original way that we wrote this. All right, everything looks good there. And returning to the code, hopefully you can see how this reads in a more logical way, right? We start with the data we want to be transforming, and then we see the first step in the process, which is to filter it. Then building on that, the next step is to group it. And then the final step is to summarize it, right? So we can read this in a way that logically makes sense. We don't have to read it inside out like we did in the first iteration. So this example gives us a broad overview of what the process looks like to work with Dplyr and how we can pipe data from one function to the next. But now let's back up a second and talk more specifically about the Dplyr functions. And for this, I'm going to go back to the book. Here at the end of section 3.1.3, which we've just gone through, they note that Dplyr's functions are basically organized into 4 groups based on what they operate on. There's functions for operating on rows and columns. There's also functions specific to working with groups once you start to group your data. And then finally, you can actually alter and manipulate your entire table of data. There's a series of functions for that. The first group of functions we're going to focus on is for manipulating rows of data. Here they highlight the functions filter, arrange, and distinct. So let's check out some examples of that. Filter, as we saw in our first example, allows us to select certain rows based on some values in our columns. So for example, here we queried for just the rows where the origin matched JFK. For some more practice with filter, let's try to query for all the flights that departed more than 2 hours late. So I'll create a new object for this. I'll just call it results2. We're still working with our flights data. We're going to pipe that to the filter function. The column we'll focus on for this is departure delay. And rather than looking for an exact match with the equality operator, we can use the greater than sign because we want to find flights where that departure delay was greater than 2 hours or 120 minutes. And to see those results, let's throw in a view function. Look at results2, and then I'm going to select all of this code and run it. And it looks like it narrowed our data set down to just under 10,000 rows of data. And if we skim through, we should see the departure delays are all greater than 120. As you might assume, there are other mathematical operators like the greater than sign that you have access to when you're filtering. So you could also do less than, or you could do greater than or equal to, or less than equal to. There's also the not equal to operator. So jumping back to our previous example, let's say we wanted to get all the flights that were originating from some airport that wasn't JFK. Rather than doing 2 equal signs, we would change the first equal sign to a exclamation point. That's the not character. So this says not equal to JFK. Both of these examples so far have been filtering on a single criteria, but we can combine criteria and actually filter across multiple columns. For example, let's say we want to get all the flights that were departing on January 1st. To begin with, we would filter by month. So we're going to look for columns or rows where the month is matching 1 for January. And then we want to add on to this. And the way we're going to do that is using the AND operator, which is a ampersand character. And we want to also look for flights where the day is equal to 1. Let's run this. And that narrowed things down to 842 rows where you can see for all of these rows, the month and the day were both 1. Let's say we wanted to filter by rows where the month was January or February. In that case, instead of using the AND operator, we're going to use the OR operator. The OR operator makes it so that either side of this condition has to be true for a row to show up in our results. So again, we're looking for January, February. So we're going to leave month equals to 1, or we're going to change the second one to be month equals February, or the second month. So we run that. That yields a lot more rows, over 50,000, because we're not looking for just flights on one day. We're now looking for flights across 2 whole months. So it's a broader search. And let's just scroll through here. I'm just going to kind of jump to the middle of our results and just show that we are seeing rows here where the month also matches 2. Expanding on this, let's say we wanted all the flights for the first 3 months of the year. We could just chain on another OR operator and look for flights in the 3rd month as well. Or a terser way we could construct this query would look like this. This is taking advantage of the in operator. So we're looking for any rows where month is in this vector of values that we've provided of 1, 2, or 3. Now that we've seen some variations of working with the filter function, let's talk about some common mistakes you might encounter, especially if you're new to programming. Let me set up an example for the first mistake. The intention of this code is to filter by flights that departed in either January or February. But notice I wrote it a little bit different than how we had written this a moment ago, where I'm reading it almost like a human would express this query. All right, we want flights where the month is January or February. All right, and that makes sense to us as humans, but to the R interpreter, this is not going to operate how we're expecting. Because when expressions like this are interpreted, basically each part of the expression is broken down and is evaluated to be either true or false. So as it's going through each row, it's going to look and say, well, is the month equal to 1, true or false? And then it's going to evaluate this part of the expression separately, right? And this part of the expression is simply just 2. When we process a number like 2 as a Boolean or true-false expression, as long as it's not 0, it's going to evaluate to be true. So the end result of this query is it's actually just going to get all of our rows because only one side has to be true. All right, so month could be 1, but it doesn't matter because 2 is always going to be true. For every single row, 2 is just true. And this is going to give us all the flights. And just to show that is the case, let's run it again. And you can see the number of rows that were returned. So we're getting our full data set back. All right, so just be aware of that. We have to be very explicit when we're working with programming in R. We have to explicitly say on both sides of the OR operator that we're looking for rows where month is 1 or month is 2. Another common mistake is when we are trying to use the equality operator, that double equal sign. Sometimes we will forget and just write it as a single equal sign, and that's not going to work because the single equal sign is not designed to check if 2 values are equivalent to one another. And in fact, if we run this again, as I've written it now, we get a very helpful error message telling us exactly what the problem is. It has detected that we have made that mistake. So just be on the lookout for that. For new programmers, sometimes the double equal sign is easy to forget, and you just need to remember to use it anytime you're checking if 2 values are equivalent to one another. Moving on from common mistakes and the filter function, another useful function when working with rows is arrange, which allows you to order your results. For an example of this, let's chain on to what we've already got here. So we're filtering by January and February, and then we're going to use our pipe operator and chain on the arrange function. And we're just going to indicate which columns we want to arrange by. So let's say we want to arrange by departure delay. We'll run this. And you can see from our results, they are ordered by the departure delay column, starting with the smaller number that was found in our results and then working up. If we wanted to flip the order, we would just wrap the column we are arranging by in the descending function, or DESC for short. And now you can see it's starting with the largest departure delay first. And in this example, I did chain it onto filter, but that's not necessary. We could just do this to our entire data set without any filtering. That would also work. If we want to sort our data based on multiple columns, we could just indicate them as additional arguments. So let's say we first want to filter it by the date. So we'll look at the year column, the month, and the day column, and then we'll finally look at the departure delay. All right, so this is going to look at our data and first get the rows with the earliest year, then the earliest month, then the earliest day, and then finally for any ties within there, it would sort it by the departure delay. Let's go ahead and look at the results. So you can see the top of the result set has our earliest years in this data set. There's several ties for the earliest month and day as well. So those are then all sorted by the departure delay, which we are still sorting in descending order. So that's why we see a larger number up top. Moving on from arrange, another helpful function when working with rows is the distinct function. One of the most basic uses of this is simply just to remove any duplicate rows. And the syntax for that would look like this. We would simply just invoke distinct without any additional arguments and pass it our data set. And let's see if we have any duplicate rows in this data set. I don't believe we do. Yeah, so that actually didn't have any impact. If we compare the number of rows in this results to our flights data, you can see it's the same number of rows. So nothing was removed, but as you can imagine, a lot of data sets often do have duplicate rows, so distinct can be useful for that. And then beyond removing duplicate rows, there are many other uses of distinct. Let's say within this data set, we want to just get a list of what are the unique origin and destination airports. So for that, we would just indicate our column names as our arguments to distinct. And based on that, it looks like we've got 224 distinct origin and destination airports within this data set. Now notice by default, when using distinct, it's going to focus on just the columns you are querying against. If you want to see the values for the other columns in these rows, you want to add the .keepAll argument and set it to be true. And let's see how that changes our results. So we still get 224 rows, and if we look at our airports, we're still seeing the same origin and destination information, but we're seeing the additional information about the rows, or more specifically, the information for the first row that matched our distinct criteria. Right, so the first time it came across a distinct row with the origin of EWR and IAH, this is the data for that particular row. And then any other rows that had this match of origin and destination are simply excluded from these results. Another useful function that's similar to distinct is the count function. So for this example, we're going to be looking at origin and destination again, but I'm going to swap out distinct with count. And an argument I'm going to add is sort is true. So it will sort our results by the count across these columns. So we can see all of our distinct origin and destination combinations with a count of flights from those combinations. And based on this information, we could see that the greatest amount of flights originated in JFK and landed in LAX. So with that, we've got a pretty good sampling of some of the functionality that Dplyr provides when it comes to working with rows. The next section in the book is a series of exercises, which I highly recommend going through because you can spend a lot of time going through each function, learning about its arguments, but the real way that you're going to get comfortable with building your queries is by solving problems. So take the time to challenge yourself with these exercises and construct queries for them. And then if you get stuck, I will include a link in the description that has solutions to these exercises. But moving on, let's focus on some functions for working with our columns. The first function they highlight here is mutate, that allows us to add new columns that are calculated from existing columns. The two examples they provide for this is adding a column called gain as well as speed. Gain is calculated by subtracting the arrival delay from the departure delay. In other words, how much time a delayed flight made up in the air. We could also calculate speed by looking at the distance and airtime columns. And let's go ahead and take this exactly as written and run it. I'll set this to a new object called results3. And by default, where we're going to find our new columns that we mutated are going to be at the end of the data set. So there's gain and speed with the values that were calculated. And you'll also notice that in our summary, it says that we now have 21 total columns, where previously this has always been 19. If we want our new columns to appear at the beginning of our table, we're going to add an argument called .before, and we'll set this to be 1. So now you can see our columns are at the beginning of the table. We could also be more specific. Let's say we wanted to add our new columns after some particular column. We could indicate that using the after argument and just specify the column name. So let's put it after the day column. So there's the day column followed by gain and speed. If we want to focus on just the columns that contributed to these new columns we mutated, we'll add an argument called .keep and we'll set it to be used. And this will actually eliminate the day column from our results because that's not used as part of our calculation. So this line essentially becomes irrelevant. So I'm going to go back to using the dot before, and I want this my gain and speed to appear at the beginning of the table. So again, I'm just going to set that to be 1. Got a syntax error there. I forgot my comma. Let's try again. And there we go. So we've got 6 total columns. The first 2 are our mutated columns, and then the latter 4 are just the ones that were relevant to those calculations. Another useful column-specific function is the select function. This allows you to narrow down which variables of data you're seeing in your results. For example, let's switch from mutate to select. And let's say we're only interested in date-specific information. And let's also throw in origin and destination. And you can see how that narrows down our results to just those columns. If you want to select a range of columns, you can use the colon character. So this would get all of the columns starting with year and ending with day. Or let's say we wanted all the columns except for those. We would just add a exclamation sign at the beginning. So we've got 16 total columns here, excluding year, month, and day. We can also narrow down the columns of data we're seeing based on the data types stored in those columns. For example, let's say we want to get just columns that have character strings. The syntax would look like this. So we're saying select where is .character. And you can see that excluded any of our numerical based columns. We do have numbers in our results here, but you'll notice these numbers are always combined with a character. So that's what makes it a character string rather than a purely numerical value. In this example, the use of where is a helper function we can use with select, and there's a handful of other helper functions that will come in handy with select as well. Let's go back to the book for reference on this. So we're under section 3.3.2 select, and if we scroll down, here are some other examples, which aren't really relevant to the flight data we're working with, which is why we don't see examples in the book, but you can skim through these and get a sense of what they would do. So let's say we want to get just columns that start with some particular string of characters or ends with a string of characters, or simply contain somewhere within that column name those characters. We could do that sort of selecting, or we can select based on a numerical range. Another use of the select function beyond just pinpointing which columns you want to see in your results is you can use it to rename the column headers. For example, going back to our last query, let's say when we're working with this query result, we want to reference tail num using snake case styling. In other words, we want it to be tail_num. The way we could make that happen is we're going to add on to this select with another argument. And we're going to indicate the new column name we want, which in this case is going to be tail_num. And we're going to set it to be whatever the column was previously, tail_num. All right, so now our results has that tail_num column renamed. Another way we could rename columns without narrowing down the columns we're seeing is using the rename function. Right? Because when we did a renaming like this with select, let's say we got rid of where is characters, what this is going to do is, yes, it's going to accomplish our renaming, but it's also going to give us just this particular column. That's what it's going to select upon. Let me go ahead and show that. All right, so let's say we wanted to get all of the columns, but just rename tail_num. We would switch to the rename function, give it the same argument, and then let's run that. So we've got all of our other columns, and then we could see that tail_num was renamed as expected. Now, an important thing to note based on some of these things I've been doing, really any of the examples so far, is notice I'm not amending the original flights data, right? I'm not actually changing the column name in our original flights data. This is only applicable to this particular query and this object where I'm capturing the results of that query. And just as evidence of that, if I were to say view my flights data, I have the original amount of rows, the original amount of columns. If we looked at our tail_num, you could see it's written as it was originally written. This data is not getting altered with all of these queries that I'm running. And for reproducibility purposes, that is the best practice, right? We don't want to change the original data to any extent that we want to alter it. We're basically making copies of it in these unique objects. And then as we look back through our code, we essentially have a history of what we did as we worked with that data. So that aside, that wraps up the sampling of functions we wanted to look at when working with columns. And just like at the end of our rows functions, there are some exercises you could go through and practice with, which I highly recommend. But we are going to skip down to section 3.4 and talk more about that pipe operator. And the first part of this section is just information that I actually already talked about when I introduced the pipe operator. It's just talking about how it provides a more intuitive way of working with our data where we could read it step by step. And then they contrast that to if we weren't using the pipe operator, where we have a series of nested functions and we have to read it inside out, which, like I said, I already went through that. So we're going to skip over that because I do want to get down to this part where it's talking about a keyboard shortcut for making that pipe operator, which I recommend getting familiar with just because you're going to use it so frequently. On a Mac, it's going to be Command-Shift-M, and on Windows, it would be Control-Shift-M. But what you'll notice if you try that, let me go ahead and show you. If I do Command-Shift-M, that doesn't look like the pipe operator we've been using, right? It's 2% signs with a greater than sign in between, whereas we've been using the pipe character followed by the greater than sign. The difference between these two is this is the pipe operator that was introduced in the Tidyverse family of packages, which is where the pipe operator actually originates. But later, base R actually introduced its own pipe operator, basically because they saw what Tidyverse was doing and they're like, hey, that's kind of a good idea. Let's create our own pipe operator. And there are some subtle differences between how these operators work, but for most of the work we're going to be doing, you're not going to notice a difference. And so the authors of the book actually recommend using the base R pipe operator for the simple reason of just it's always available. You don't have to make sure that you have the Tidyverse library loaded, especially if you're not using it for anything else. It's basically just built in. So what we want to do is we want to customize our keyboard shortcut so that when we use it, it's generating the base R pipe operator. And so to do that, I'm going to go to Tools, Global Options, go to Code, and check the option to use native pipe operator. This does require R version 4.1 or greater. If you have the latest version of R, you should be good. So I'm going to check that, apply my changes. And now let me run my keyboard shortcut again. And perfect, it gives me the base R pipe operator. So that syntax note aside, moving forward, the last set of functions we're going to focus on in this chapter is for working with groups of data. So this is section 3.5. And we'll start with basic grouping using the group by function. Let's set up some code for this. And for our first example, let's group our data by the month. So I'm going to run that. And then if we view this resulting grouping, we're not going to really see any effect here. It's just going to show all of our data. So instead, what I'm going to do is let's just output this results object that we just created with the grouping to the console. This is going to give us some behind the scenes information about this data based on the grouping that we did. So I'm simply just going to execute results for. Right, it outputs information about this tibble, and you'll notice it indicates that it's been grouped. So it's grouped on month, and it shows how many groups were created. So the group by function in isolation isn't very interesting, but where it starts to become useful is that any subsequent functions we apply to these results will be applied to those groups. We actually saw an example of this earlier. So scrolling back up, one of the first things we did was we grouped our data by month, and then we chained on the summarize function to figure out the average delay per month. And let's just replicate that example again. So a much better representation of the utility of grouping our data. We see the average delay across all of our month groups. For another example, let's try some filtering chaining onto grouping. Let's say for each month, we want to find what the max departure delay was. So we want to look at the departure delay column where it equals the max value for our groups. And for this, we're going to use R's built-in max function. We want to find the max for the departure delay column. And just like when we were calculating means, we want to remove any not available or missing data. And let's see what this gets us. So as expected, we got 12 results back. So one row for each month, or one result for each of our groups. And from this information, we could see for a given month, say here for January, the max departure delay was 1301. For October, it was 702, and so on and so forth for each of our unique months. Now, the other information we're seeing, remember that when we're using filtering, it's going to find the first row that matches our criteria. So this happened to be the first row that had the max departure delay for the given month, and this is the other information associated with it. If we wanted to simplify these things, because we're really just interested in the month and the departure delay, let's go refine our query. And let's narrow down using select to just month and departure delay. And let's also arrange our data by month. And that's much clearer, allows us to focus on just the relevant details. Another set of functions that's useful when working with groups is the slice family of functions. In section 3.5.3 of the book, you can see a summary of these functions. So things like slice head and tail for getting the first or last n number of rows from a group. You can also slice out rows based on smallest or largest values for a particular column, or you can slice out random rows. An example the book highlights is using the slice max function, where they find the flights that are most delayed upon arrival at each destination. So they start by grouping by the destination. Then from those grouped by results, they're going to slice off the row that has the max arrival delay. And we're looking at a single row here because they indicated n is 1. And then finally, just to highlight the destination, they use the relocate function to move it to the beginning of the table. And let's go ahead and just run this. So because we've grouped by destination, we should see unique destination for all of our results. And then for each of the destinations, if we look at arrival delay, the number we see here should be the max arrival delay for that particular destination. And just for the sake of practice, let's write some code to check our work. For example, let's look at the destination ABQ and make sure that 153 is in fact the max arrival delay. So going back to my code, let's set up a new object. First thing I'm going to do is let's just filter our flights to rows where the destination is ABQ. And then from those results, let's layer on another filter to find the max arrival delay. And then finally, for the purposes of clarity, we will select just the columns we're interested in. And perfect, looks like our max delay for ABQ is 153, which just confirms what we saw in our previous query. Moving on in our discussion of working with groups, so far everything we have done has grouped by a single column, but you can group across multiple columns. Let's see an example of that. This time, instead of grouping by just month, let's also group by year, month, and day. So here you can see, inspecting our resulting table, that we have grouped by year, month, and day. So this yielded 365 groups. And then, for example, let's say we wanted to count how many rows, or in this case, flights we had for each of those groups. We could tack on, let's use the tally function here. So the tally function added this n column where we could see the total number of flights for each day of each month of each year. And with that, those are the key features you're going to encounter when working with groups of data. There are some additional miscellaneous things covered in this section in the book, including ungrouping and alternative syntax using the by argument, and as always, some exercises. I don't think these are critical to the common things you're going to be doing when working with group transformations, but definitely take a moment to skim through them. And there's also a nice case study you could take a look at the end. But with that, this concludes our overview of data transformation. For a quick summary, we've looked at some functions that help us to manipulate our rows, our columns, and our groups. And along the way, we saw how the pipe operator can make the syntax for doing all of this just a little bit more intuitive. Looking forward in the next chapter, we're going to go back to workflow and talk a little bit about code style.